Hello, my name is Jeannie Quillen, and my presentation today is going to be about the Ross Sea, the characteristics that make up the Ross Sea, its community structure, and I'll briefly discuss its potential for conservation. So, relatively few marine environments remain fairly untouched by humans, and one of those areas is located off the coast of Antarctica that you can see here in that picture on the left. This is the Ross Sea, and it's a generally shallow marine region that's approximately 370,000 square miles in size, and it is one of the most accessible of Antarctica's fringe seas. A survey was conducted that determined that human impacts on the human impacts on marine ecosystems, and they noted that the Ross Sea is one of the most pristine and intact ecosystems that are left on Earth. This does not mean, though, that it isn't beginning to experience anthropogenic changes. So this paper will investigate the physical characteristics and uniqueness of the Ross Sea's community structure and evaluate the validity of conservation efforts. So to gather data on this subject, I utilized Oregon State's website. So I went to www.oregonstate.edu, and then I went to the library's link there. Once I clicked that link, it took me to the page that you can see here in this image. So I used the OneSearch tool, and the keywords that I used for this included Ross Sea, ecology, ice shelf, seafood, food web, sea ice, and combinations of those. The literature that I used, I restricted to peer-reviewed journals that had online full-text availability, and any web references that I did use, like from Google, I restricted those to reputable sources like Encyclopedia Britannica and university websites and the like. And then I went ahead and I synthesized the information that I gathered. So to start the results and discussion section, I'm going to discuss the physical characteristics of the Ross Sea. So the Ross Sea is a very unique and stark ecosystem. The coast of the sea is dominated by the Ross Ice Shelf, which is the largest ice shelf in the world. For most of the year, much of the Ross Sea is capped by ice, but it does have seasonal and interannual variability in both thickness and extent, which you can see in the top image here. Places of unfrozen seawater that are surrounded by pack ice do exist, though. Those are called polynyas. You can see those in the bottom image. There are two, one on the left of the image and one to the right. And these polynyas are extremely important to the Ross Sea ecosystem. They play a role in the life cycle of multiple species, and they support advantageous conditions for high primary productivity. So as such, the Ross Sea is viewed as an important carbon dioxide sink in the Southern Ocean region. The mean depth of the Ross Sea continental shelf is around 600 meters. Air temperatures range from -60 to 10.1 degrees Celsius, and water temperatures range from -1.86 to 3.2 degrees Celsius. And the photoperiod also ranges from 0 to 24 hours, and therefore seasonal variability in primary production is experienced. So interestingly, global climate change is having an inverse effect in the Ross Sea, increasing the ice cover extent rather than decreasing it. And this is a phenomenon that is explained chiefly by fluctuations in the Southern Annular Mode, or SAM, and the El Niño, Southern Oscillation, or ENSO. So the left image here is a depiction of the SAM cycles, and then the right is a depiction of ENSO. So, ENSO is in fact a tropical climate oscillation, but it affects the globe because of atmospheric connections. So ENSO, coupled with the positive phase of SAM, which is the principal mode of variability of atmospheric circulation in the high southern latitudes, and then this has a strong influence on the seasonal retreat and advance of sea ice. So this is in stark contrast to the sea ice loss that is being experienced in West Antarctica, and that's linked to increasing atmospheric and oceanic temperatures in addition to increased strength of warm northerly winds. So not only does the Southern Ocean sea ice have a strong influence on physical and biological processes in the water surrounding Antarctica, but it also has a hand in regulating global climate via ocean circulation, albedo effects, and heat exchange via oceans and atmosphere. So sea ice in the Ross Sea is one of 3 main sources of bottom water in Antarctica, and thus has a strong influence on the global circulation of the oceans. So importantly, the Ross Sea is predicted to be the last area in the world with sea ice year-round. So if global warming is not curbed by the end of the 21st century, the sea ice extent of this region will be greatly reduced, with very strong implications for the future of this marine food web. So, speaking of marine food webs, we can go ahead and talk about community structure and dynamics. So, the Ross Sea has a very diverse community of organisms, the base of which is supported by roughly 100 species of phytoplankton. This includes diatoms, haptophytes, dinoflagellates, and cryptophytes. Additionally, benthic Antarctic communities are some of the world's most ecologically stable communities, with high levels of endemism, biodiversity, and biomass. Now, pelagic organic matter plays an important role in structuring these communities, and inputs are closely linked to hydrological conditions. So interestingly, one of the most complex community assemblages found in the Ross Sea are those of the 3-dimensional sponge anthozoans, with high rates of predation, competition, and symbiosis. Detritus in certain areas, such as shallow waters, can also be very important to benthic communities. For example, the Weddell seal preys intensively upon Antarctic toothfish, and they can potentially reduce the biomass to 0 where seal concentrations are high, but in doing so, the seals are simultaneously providing a very concentrated supply of detritus to the benthos in the form of these uneaten carcasses. Now, the aforementioned toothfish is one of approximately 80 fish species that make up the fish fauna of the region, 53 of which are of the endemic suborder Nodothenoidea. That's a hard one to pronounce. These fish dominate the biomass of fish of the Ross Sea at greater than 90% and are therefore highly important to the Ross Sea food web. I have a picture here that depicts the food web in the Ross Sea, a very rough depiction, I should say. It's incomplete. But I also included an image of a baleen whale and the krill that they feed on. Now, the Antarctic silverfish, along with the mesozooplankton crystal krill, are considered to be the keystone species in the Ross Sea shelf waters. So typically, the Antarctic krill is an ecologically important species elsewhere in the Southern Ocean, but they're practically absent in the shelf waters of the Ross Sea. So again, the Antarctic silverfish and crystal krill. These species are support a number of animals, including whales, seals, birds, both penguins and seabirds, fish, and invertebrates. So unlike the linear food web that's presumed for much of the Southern Ocean, in which Antarctic krill is the keystone species, the Ross Sea shelf food web is a complex assortment of predator-prey interactions. The aforementioned nodothenoid fish are very key players in this web. So 1, as predators that dominate most of the available niches, 2, as prey that are essential food sources for each other and most top predators, and 3, as the major linkage between lower and higher levels of the food web. So one important example of this is the Antarctic toothfish, which you can see here. This is a large predatory species that can grow to more than 4 feet in length and has a lifespan of up to 50 years. So they basically act as the shark in an ecosystem that lacks many large predatory fishes. So the toothfish feed largely on Antarctic silverfish, and in turn are a food source for various large marine predators. This includes toothed whales such as the sperm whale and an orca seen here, Weddell seals, and possibly even colossal squid. Commercial fisheries for the Antarctic toothfish have been underway since 1997, yet relatively little is known about their life history, which does make management decisions difficult, and the threat of overharvest very real. So scientific surveys have shown that the toothfish is now harder to catch, and the average size of fishes caught has declined in recent years. A way to ensure that trophic cascades don't commence is to ensure that critically important habitat for all of the life history stages of this fish are protected. And as discussed previously, primarily the Ross Sea shelf and slope. So should harvest continue, particularly if it's at a rate that is unsustainable, one would predict a decrease in top predators that depend on these large fish for survival. So for example, there are genetically distinct groups of orca in the Antarctic that feed almost exclusively on Antarctic toothfish. Then these would face a serious threat of extinction should the toothfish stocks be depleted. Additionally, removing these predators might increase the abundance of lower-level fishes and krill, which could impact planktonic dynamics in this ecosystem. It should also be emphasized that there is strong seasonality associated with Ross Sea food web dynamics. So the base of the food chain, i.e. phytoplankton, respond rapidly to changing conditions on daily, monthly, as well as seasonal scales. However, it's rather poorly understood how long-lived organisms, such as benthic fauna and top predators, respond to variation in primary productivity. All right, so the Ross Sea is the most spatially extensive and productive region in the Southern Ocean. Unlike most other places around the globe, the Ross Sea has yet to be impacted by widespread pollution, overfishing, and invasive species, and the top and middle trophic levels have yet to be radically impacted by anthropogenic forces. Furthermore, many of the aspects of the Ross Sea food web are unique to this region, and it makes it an excellent location for studying the ecology and biotic influences in these cold water communities. Additionally, current climate change trajectories and the foreseeable depletion of global sea ice, with its implications for ocean circulation and atmospheric circulation, should not be overlooked. So the Ross Sea is expected to be the last remaining area on Earth with sea ice year-round, and will likely be an important refugia for ice-dependent species in the coming years. Conservation of this area would be an excellent step towards preserving one of the last remaining pristine natural environments on Earth. And now, while there are certainly ecosystems that are arguably more in need of protection, an opportunity such as this will not present itself ever again, and that in itself to me is something well worth considering. All right, now that concludes my presentation on the Ross Sea, and here is my literature cited. And I will post a script for this with my presentation. Thank you for watching.